Hello, my name is Ryann Hallback, and I am a Principal Intelligence Analyst here at the Vertex Project. And today I want to walk you through and show you how I use Synapse to perform malware analysis. Specifically, what I want to show you is how I use Synapse to perform malware analysis and threat clustering using a notional scenario, and really a use case that's very common to us. In this scenario, we have our IR team that came to us with a set of suspicious files, and they want us to take a look at the files that they collected from a client environment that they suspect is compromised, and they want us to help us rapidly triage those files to aid them in their investigation. Specifically, what they want us to do is analyze the files to determine if they are benign or malicious, if they are known to us previously, if they're associated with any known malware families or threat groups. And then lastly, help them identify any additional IOCs that they can use on the ground to help them with their investigation and possibly any remediation efforts that they may need. One of the first things that I do whenever I want to perform any type of research or analysis is create a fork view. In Synapse, a fork view is essentially an analytical scratch space that I can work from that will allow me to ingest data, add tags, make any assessments that I want without potentially affecting the underlying layer that I'm working from. So what I've done is I've created a fork view, and that's where I'm going to be doing my analysis from today. So this is my fork view here that you can see. And the benefit is that once I work in a fork view, any data that I create, I can then choose to merge into the underlying layer, or I can optionally discard some of that data in part or in whole as I see fit. The IR team alerted me of their need for my support via a Jira ticket. They created a Jira ticket. Here is the Jira ticket right here. They're indicating that they have a set of suspicious files that they want me to investigate. And they've even included an attachment that has the hashes for those files. One of the great things about Synapse is that I don't have to go to that external Jira instance, however, to be alerted of that research request. Instead, what I can do is leverage Synapse and automation. The piece of automation that we've leveraged here is cron. And we have a cron job setup that will poll that Jira ticketing system every 5 minutes to see if we have any new research requests. And if we do, it'll create a ticket for it and also create those additional nodes that are represented in that ticket. So what you see here is the Jira ticket that's created. You see the properties that we've created here in my node panel. You see the tags that were ingested and pulled in from Jira. And also we have the indicators that they want me to research. So we've modeled them as SHA-256 hashes here. And also we've created some file bytes nodes and tagged them to indicate that they are in part of the investigation or the case that the IR team is working on. So since they want me to investigate these files specifically, what I'm going to do now is right-click and query using my query helper. And I'm just going to lift those files alone to do some research. I just lifted one, so let me go back and lift them all into my view. So using my multi-query option, now what I have is all 3 files listed here that I want to investigate. One of the things that Synapse is good for is serving as a system of record. This allows me to store context, not just for my current analysis effort, but for every effort that I've previously done or my teammates or my organization, anything that we've previously done and annotate it in the system. So if I click on the file, they want to know specifically, do we have any existing context for these files? Do we know anything about them? Have we previously seen them? I can quickly take a look here on my right to see if I have any properties that are populated and also any tags. The properties are going to represent metadata and key data that were extracted from the files and then placed on the nodes themselves in the form of properties. And then tags are going to represent things that we use to cluster the nodes and represent assessments or things that will help us manage our data in our system. So clicking on these files, I don't have anything that's really telling to help me, ascertain what these files are. If I select all of these files and then pivot over in the graph to see what nodes are directly connected, I don't have much there either. What I have are the hashes, which are the properties on the files. And I also have the paths where these files were observed on the client systems, but that's about it. So I really don't have a lot of context to tell them right now at this point. So one of the first things that I want to do is leverage Power-Ups to pull in more data and extract more data from these files to help, guide my analysis in some way. So when I'm going to leverage a Power-Up, there are several ways that I can execute it. One of the things that I can do is run it from the command line. Here, I'm going to leverage a node action to run my file parser Power-Up manually. As I execute my Power-Up, what I'll show you is what our Power-Ups look like. And essentially, Power-Ups are tools that allow us to extend the base functionality of Synapse. So that can be anything from an API connector that lets us go out to third-party tools like Alien Vault or blockchain, or it could be something like I just executed, which is the file parser tool, which is something that is internal to Vertex, but it's a tool that allows us to extract key data from a file and model it directly in our system. As I refresh my query, what I see here is what the file parser returned for me. It actually populated more properties for me for those files. So it gives me more key information about what I'm looking at. Prior to executing the file parser, I didn't know that these files or one of the files was a Word document, nor did I know that these two files were executable. So it pulled out some of the key MIME information. It also pulled out the PE compile time and the import hash information, all of which is useful because it's giving me insight, but also because as I pull out properties on this file, I'm able to use these properties to pivot and identify other files in the system that may overlap and that I could potentially cluster with my current file set and give me more information about the file that I'm investigating. So if I execute this query for an example to lift all of the files in my system that have the same PE compile time property as my file, I'll see that 2 additional files were pulled up. Looking here, I have a file that has some tags on it for context. I have a tag here indicating that this file is a part of the code family of Froyo. I can look at my tag definition to help me, understand what this tag means. And if I go down and hover some more, I can see that this CNO mal Froyo tag indicates that we have assessed this file to be malicious internally. And I also see a couple of other things about the files that have the same compile time as the file that I'm investigating. I see that it is a part of a threat cluster that we have internally named as Sundance. And also that this particular file was previously reported by NetScout, and it was given the association of Cobalt Group. So this is all great context that I can use as initial information to help guide my investigation. If I click down, this is the file that we're currently investigating. And this is another file that was brought up, and it actually has the same context in the form of tags as well. If I go back up and run my previous query, going back, in addition to leveraging some of the properties now, I can also select my files and pivot now to see what context I have in the graph and what additional nodes were created in the graph by my file parser Power-Up. Using my scroll to form, I can see that additional nodes were created, like the PE resource used to represent the resources that are embedded in these files. And then I also have things like VE version information, PE version information. So this is indicating that one of the files has a file description of a Froyo, which is interesting because what I saw was that I had a malware family named Froyo, and maybe that's where the malware family name came from. I also see that I have a file name here. Versioning information indicating that one file is associated with Microsoft. That could be an indication that it's in fact a legitimate Microsoft file, or it could be spoofed and not legitimate at all. But we can see by pivoting over what additional information we're able to glean about these 3 files. So that's just all context that I was able to obtain by running my file parser Power-Up. Now let me go ahead and pull in more data using some of the other Power-Ups that I showed you. Normally, I would leverage automation to run and ingest more data. Really triggers. Anytime I have something like a new file being created or a tag being added, I can in fact have automation leveraged to call a Power-Up. In this case, I chose to use a node action to just call it directly. Specifically, what I did was I called a macro directly for the purposes of this demo. What a macro is simply a set of saved storm code that I can show you here. that contains a set of commands, and they can be advanced or they can be, as basic as you want. In this case, we just have a macro that we call enrich. And in this case, any form that this enrichment macro encounters, whether it be an IP address or a file bytes node, in our case, is going to call a set of power-ups to pull in more data for us. So when I called this enrichment script or macro, what it did was it went out to VX Intel, Alien Vault, Virus Total, so on and so forth, and it pulled in additional data from their APIs to help us get more context about these files. When I go back to my research tool, what I see here is exactly what happened when I ran my enrichment macro. I had over 19,000 edits take place on over 3,000 nodes in the system. So that's a lot of data that was pulled in. If I refresh my query, now I can see exactly what context I have, additional context I have about these files. One of the first things you may notice is that some of the files, they actually changed colors. They were all originally orange. Now we have one that's like this purplish pink color, and we even have one that's white. This is because we have tag coloring rules in place. And this is just a feature that we provide to analysts to allow us to customize our analytical experience as we're working in this environment. So if I have something that I want to be colored blue, that I want to, have faded away from my view, or if I want something colored red because I want it brought to my attention, I can leverage our tag coloring rules here to do that for me. So in this case, looking at, let's say, this third file, I have this wscript.exe file. When I look at the file, I can see the PBD path there. And if I come down here and look at some of the tags that are applied, I can see now why this file is in fact white. And that's because we have a tag coloring rule in place that indicates that if you have anything that's listed or tagged as being whitelisted, go ahead and make that white. That's going to let me know that, hey, it's whitelisted, it's benign, according to certain third-party vendors. So in this case, we have a tag indicating that hybrid analysis has assessed this file to be malicious. That's some of the data that we pulled in using our Power-Up. If I look down, I have additional tags that we also pulled in from Virus Total. Virus Total has indicated that it's associated this file as being linked to a known distributor, which means that it's known and it's also deemed as trusted or non-malicious. So this is good context that I can use to help guide some of my initial, analysis and assessment. And if I pivot over, if you recall, I just mentioned how some of the VS version information, we did have a file that had some versioning information that mentioned Microsoft. It looks like this particular file is the one that in fact had that Microsoft legal copyright data. Sometimes this information can be spoofed, but because it's associated with trusted software and it's been deemed so by two entities, I'm just going to trust that assessment and just say, hey, in this particular instance, it looks like we may be dealing with a non-malicious file, which can happen a lot of times when you're looking at malware, as you know, because threat actors commonly use legitimate files to help facilitate malicious activities. So that could be what we have going on in this case. So in this case, I'll say that the first file that I'm taking a look at, it looks like it may be, in fact, benign. Now what I want to do is take a look at these two files to see if I can figure out what they are. Looking at this Microsoft Word document, if I look at the tags, I can see that hybrid analysis has assessed it to be malicious. And Virus Total has given me some information to let me know that, it's a Word document, it's obfuscated. And then it also has some embedded macros that I may want to take a look at. This particular file right here, what's interesting is it now has a CNO mal tag, a froyo applied. And if I hover over it, I can see that that particular tag means that this file has been assessed to be malicious. And specifically, it's been assessed to be associated with the malware family of froyo. Directly below it, it also has an int review tag, which is a tag that we use internally to tell us as analysts that we need to review the tag that's applied of CNO mal.froyo to make sure that that's a correct assessment. The way that these tags got applied, they didn't come in from a third-party API like our hybrid analysis tag or virus total tag. This is something that was actually applied using and leveraging triggers or automation. So if I go over here to our trigger page, which you can see is that we actually have triggers in place that will propagate tags that are observed on Yara rules. And that's actually what occurred. So I'm going to take a look at that Yara rule and see if I can make some determination about it to see if this tag is in fact accurate. And if so, then I have some context that I can leverage that was put here automatically. It's not something that I had to do as an analyst. So I'll select both of these files and pivot over and see what I can glean or tell. Since we used power-ups like Alien Vault and Shodan and Virus Total, I was able to pull in a lot of good data. If you recall, originally when we did our initial pivot, we only had a few things that were connected to these files. Now we have over 1,400 nodes that are connected to these files, these two files. And this is a lot of data that I can scroll down and try to use to help me get more information about them. One of the first things that I like to do when I'm trying to perform malware analysis is go to the antivirus information to see if some of our antivirus vendors have actually indicated that this file is malicious or not. So what we have here, I've just scrolled down to our AV file hit nodes. And what these nodes represent is exactly what it sounds like. It represents antivirus hits that were observed on these files. And what you have here in this column is a signature name that they refer to the file as. So we have several AV vendors that have in fact indicated that these files are malicious. It's super helpful when an AV vendor gives a file a specific name and not something generic. So we have a lot of generic hits, like indicating that this is suspicious or that it's just a downloader. Sometimes what you're able to get, however, are very specific AV file hit names. But in these two instances, it's just generic. We have malicious, we have unsafe. So although it's not telling me what malware family certain vendors may associate with these files, it is letting me know that they have assessed them to be malicious. And we do have a lot of hits from a lot of vendors, and that's helpful. So in addition to looking at things like our AV file hit information, there are other things that I want to take a look at as well. And one of the other things that I want to take a look at are our Yara matches. If you recall with one of our files, we had a file that had a CNO mal froyo tag on it. And the reason that that particular file was tagged with that is because we have that trigger that I showed you that will propagate automatically any tags from a high confidence Yara rule over to the file that matched it. What you see here are Yara matches, and Yara matches are nodes that we create in Synapse to store an actual match that occurred from a Yara rule to a file. So in this case, what you see is a match indicating that we have a rule in our system, a Yara rule named suspicious doc, or word doc, and we also have a rule named froyo backdoor. And these two rules have hit on our two files. If I select these matches and pivot over, I can actually take a look at the rules themselves. First, we have our suspicious word doc rule. In this particular rule, if I hover over it or if I double click, I can see what's contained in it. And I can take a look to see if I really want to trust, what it's saying, or just get a better idea of what it's actually detecting. And here, what it looks like is we just have a generic Yara rule that's looking for Microsoft Word documents that could be malicious. So in this case, this is something that is interesting because it's helping confirm that this looks like it is a malicious Word document, although we don't have a malware family. Now, this next rule actually has the tag of CNO mal froyo. And if I double click on this, I can see the contents of this particular rule. I can see who wrote it. Sometimes we just leave it as a Vertex project or the particular author. And if it's high confidence and if it's something that I want to trust, this is great because what it means is anything that hit on this rule, I'm able to, in high confidence say that, what, this is actually a froyo backdoor. So one of the samples that our team passed us, it's looking like it is in fact a froyo backdoor. And then I can also pivot, let's say, from these two rules again to see all of the files that we have in our system that have previously hit on these rules. And the benefit of doing this is I can look at these files to see, what threat groups they're, previously associated with and what other contexts I have. For an example, I have additional files that also hit on the same, suspicious Word doc rule. And this was also attributed to the Sundance malware family, and it was previously reported by NetScout as well. So I'm starting to see a theme kind of, pop up here by me looking at some of the context that I have in our system. If I use my breadcrumb trail here to go back to, the results of my query, we took a look at the AV file hit information. We took a look at some of the YAR rules. Other things that we can take a look at that may be interesting is some of this sandbox execution data. So for an example, what HTTP requests happen, when these files call out. In this case, we see it call out for a file named info.txt that may or may not be useful. Something else that may be useful, however, is if we wanted to take a look at some of our DNS requests. DNS requests are always extremely interesting to me whenever I'm doing malware analysis, because whenever a file makes a DNS request for a particular domain, which is what this request node is used to represent, a file or some type of service calling out to make a DNS request for a domain. These domains can be indicative of C2 infrastructure. They could be benign domains that could be used for connectivity checks or just a part of network activity that commonly happens in a sandbox. However, in the cases when it's not, it's good for identifying potential C2 infrastructure. So in this case, we see our 5190 file call out to a Microsoft, looking domain. And then we also have this 8F0D file call out to another domain as well. If I go ahead and select these two DNS requests to pivot over, what I'll see is that these domains, they have some coloring applied, which indicates to me, hey, these were previously known to us. And if I look over here to my right, what I see is I have some context already for these domains. I see that my first domain is malicious. It's associated with the Sundance threat group. We've also applied a TTP tag to indicate that whoever is using this domain or whoever created this domain, they're trying to masquerade as a legitimate Microsoft domain. And this domain was also previously reported by NetScout. And the same thing for this domain as well, associated with Froyo, Sundance. We have another masquerade attempt here, and it was also previously reported by NetScout. The thing that I want to do now is, since I'm starting to, notice a pattern of, the Froyo malware family that keeps popping up, the Sundance threat group keeps popping up. I see now that these domains are in fact malicious. So that's, that's already known. That's context that I can now pass to my IR team to say, hey, if we see some activity and logs that are calling out to these domains, that's something that you want to be concerned about. I can also kind of pivot and tell them, more about the Sundance threat group family, or exactly, how these files are getting into a customer's environment. If I pivot over to some nodes that are connected directly to those domains, what I'm going to see here is additional information that may be useful for the IR team that I can pass over. For an example, I have a DNSA record that we have tagged and associated with the Sundance threat group. I see that this Outlook domain has previously resolved to this 80 IP address. Maybe that's something I want to pass them as well. Maybe I want to pass this IP address to say, hey, maybe you want to scan some of your customer logs to see if you see this IP address, because it's previously been associated with that threat group as well. What I also have here are a set of additional DNS requests. And these DNS requests are interesting because what these represent are requests that other files have made out to these domains. And this is interesting because what this could indicate are other, malware families that also call out to this domain. It can also indicate, a pivoting point in a way in which these files got into the customer environment. So I want to take a look at these additional DNS requests here, and I have about 20. So I will go ahead and select all of these and pivot over to the files that made these DNS requests. What I see here is this is the file that I am currently investigating, but I also have another Word document, which is around the same size. that was previously attributed to Sundance. So that's helpful. I'm kind of seeing some similarities line up between these two files. I can see that I have other executables that call out to these domains. Once again, I'm seeing froyo be consistent. And then if I go down, what's interesting is I have a different file type that shows up, and this is an RTF. And looking at the context, I see that this one is a little bit different because this is actually a phishing payload. So this tag indicates that we have observed this file serve as a phishing payload as a part of a phishing message. What I also see is that this file has a CVE tag that was pulled in from our virus total Power-Up, indicating that it's a part of these two CVEs, these two exploits or vulnerabilities. So that's exciting for me to know as far as context. I would then pivot from this file to try to figure out what is it exactly that this RTF is doing. And more specifically, how did it serve as a part of a phishing email? Tell me more about that activity. So what I'll do is I'll come here to my scroll to form and click down to this INET email message attachment. This particular node represents that actual RTF as an attachment. What we've done is taking that file and we have represented it as an attachment in our system. And this allows me, once again, to use things like some of the properties like this sepal rules .doc name property to actually pivot over to maybe identify other files in the system that have this exact name, for an example. If I pivot over from this attachment, what it then takes me to is the message that attachment was extracted from. So this message has all of the properties, broken out. And if I then pivot from the message, now I can see everything that is directly linked to this message where the attachment was observed. So this is giving me some good insight into what our IR team could be dealing with on the ground. Specifically, it's showing me who was the target of this phishing message and what FQDN was being targeted. It's showing me who the message was sent from. So we have this email address that is actually malicious. This is the phishing sender. This is, associated with Sundance, obviously, and this was also reported by NetScout. We also have the email header information that was broken out. So we see the subject and we see the return path. And then we have the attachment that was a part of the phishing email. And we also have the link. So if I take a look at the attachment, this is a phishing payload. If I pivot over to the file, this is the file that I just pivoted from. This is the file that was the payload. This is a CVE. And if I pivot over, I can see that this is the file that calls out to the domain that we're investigating. So that's great context, right? So maybe our IR team could be encountering the same thing on the ground where one of these files was actually an attachment for a spear phishing email. So I can go back and say, hey, maybe you want to check their email appliance to see if you can identify a spear phishing email as being the initial infection vector. Something else I want to take a look at is this link. So our spear phishing email actually contained a link in the message, which we have modeled out. If I take a look at this link that was extracted from the message and continue to pivot, what I have is the actual file that gets downloaded when you access this link. So we represent that using our URL file node here. And then when I pivot over to this actual file, I can see what we have on this file. I can see that we have a file that has been attributed to the froyo malware family. And then pivoting from this file, what I see is the DNS requests that are made out to this domain that we're investigating as well. So it's two interesting things that have happened. I've been able to see that I have an attachment that is linked to a spear phishing email, and that attachment calls out to the domain that we're investigating. And that attachment was actually, a CVE, which could be, what our Word doc is, in fact, right? Because we are investigating a Word doc. And then also have a file that our IR team passed over, which is a Windows executable. And this particular executable is showing up as being, as a part of the froyo malware family, which is something that we had our automation help us determine by applying that tag and propagating it from our YAR rule. So I'm able to, quickly ascertain what I think these files are, exactly what they're doing, and who they may be associated with. I mean, if you look here at my breadcrumb trail, what is really impressive about it is that I was able to do that all just by clicking through the graph and leveraging existing information that is actually, in my system. Not having to execute a ton of storm queries, not having to actually go out to these third-party vendors manually and log into, several external systems. Instead, I was able to use Synapse as this single pane of glass and have it do a lot of the things for me regarding connecting to external systems and pulling in more data and storing that context that I need. So now that I've kind of, pivoted and walked the dog, I think I have a good idea and, of what's going on here. And so what are my next steps? What would I do? We store all of our context directly in Synapse. And the benefit of doing that is so that anyone who comes here, when they run this query, for these 3 files, they're able to, determine what these 3 files are. So one of the first things I want to do is actually apply tags to indicate my assessment that I've made as an analyst. If you recall, for this first file, I have assessed this file to be, in fact, benign. And the way I'm going to indicate that is by applying a tag cno.common to indicate that this file is common to us. It doesn't mean that it's not used maliciously at all, but by itself, it is in fact common and it's benign. So that's what you should know when you take a look at this particular file. These 2 files are a little bit different. What I see is that these files are associated with our Sundance, threat group. In this particular file right here, while I wasn't able to determine, a particular malware family, or, say that it's a part of, a particular CVE, what I am able to tell you is that this is associated with our Sundance threat group. And because of that, I'm going to go ahead and apply a Sundance tag. I do know that it's also malicious. And because of that, I'm going to apply a CNO mal tag. So I'll go ahead and apply that tag to this guy. And then lastly here, the only thing I need to do is come in and apply the Sundance own tag to this particular file. So I will apply this tag and then come in and remove the int review tag. Because I've actually reviewed it, I've reviewed the YAR match and I agreed with the assessment that it is associated with the Froyo malware family. So I will remove the full internal review tag. Now we have updated context for this particular file set in the system. So when our IR guys come to the system, they'll have all of the context that they need. One of the last things that I could do, if I wanted to help them know that I'm, done with my investigation, I can come down here to my JIRA ticket and leverage a node action that I've created to resolve the JIRA issue, to alert them to say, hey, I've completed my analysis. You can now log into the system and get all of the context that you need. So I've closed my JIRA ticket. And then lastly, what I would do is merge, my research and merge my assessments down into the layer that's underneath. Because the data that I pulled in, I actually want to keep. I'm confident that the assessments that I've made, that they're accurate and should be leveraged by everyone in the system. So lastly, what I would do is merge this into the view below so that anyone who logs into the system so that they can access that data. So what I was just able to do here relatively quickly was connect data that was collected from an IR investigation with threat data that was already recorded in our system. Based on the data that was provided from Powerups and the data that was already connected in the graph, what I was able to know and ascertain was just that 2 of the files were in fact malicious and 1 was benign, able to associate it with an actual malware family and threat group, and actually wave 1 off and say that it was not associated with any maliciousness within itself at all, although it may be associated with malicious activity. That concludes what I wanted to show you for this malware analysis demo. Thank you so much for tuning in. And if you ever want to check out any more of our use cases Please take a look at our website and YouTube channel to check out more blogs and videos and see how you and your team could leverage Synapse for various analysis workflows. Thank you so much.